Okay, welcome back. So, uh, let us discuss about the construction and maintenance of sanitary sewer. So, in this topic, uh, I divide the topic into three. We have sewer construction. So, we discuss about uh, the construction, what should be the method for the construction and some equipment used during the construction and some technology used during the construction, especially to open the pit, to make a trench, to lay the pipe, to connect the pipe, etc. And after that, we go to number two, which is the operation and maintenance of sewer. Uh, So we are going to discuss about what should be the what's what should be the method to maintain the sewer based on the old technology and new technology. And number three, that's the last discussion is about sewer sewer safety. So for the safety, so what should be, I mean, what are the do, what are the don't, we should we should be aware of. Okay, so let us discuss about the sewer construction. So in the sewer construction, there are 14, I list down like 14 points that we should be aware of. So it consists of like responsibility. Uh, responsibility, as you know, the responsibility we have two main responsibility, two main party to be responsible during the construction. One is the engineer, another one is the contractor. So let's see what are the responsibility of the for the responsibility for the engineer and a responsibility for the contractor. And number two is line and grade. So line and grade. This is line and grade. So this is very important because you know the sugar can be flow. The sugar can flow based on the slope. Okay, so if the line and also the sugar is placed in correct alignment based on the line, and the grade is about the slope. So if they are not put at the right line as well as put at the correct grade, so it will be a problem for the construction. It's uh, for the flow inside the pipe itself. Okay, I'm not talking about the law. Of course, if you put it wrong, so it will be, if it is not correct based on the plan from the engineer, it will be a problem. Meaning that the customer can sue us, can sue the engineer and also the contractor. So, but in technical part, it will be a problem with the flow. So it could be like no flow, or the flow will be not as expected as designed, because we did design this in the previous. You remember we did have the example one and example two regarding the sugar design. So slope is a very one of the important parameter to make sure that the velocity will can be achieved as like more than zero point 0.6 of the partially flow inside the pipe. Okay, number 3 is classification of excavation. So as you know, to make line and grade, so we have to encounter the excavation. Even the, you remember the minimum invert level, invert depth is 3. It's 3 meters. So basically you need to dig a trench. You need to dig a trench from the beginning. So sometimes we encounter a different type of soil. So sometimes it's soft soil, sometimes it's normal soil, sometimes it's rocky condition, etc. So different soil and rock condition, we may need to have different strategy to do the excavation. So we have number 4 is a hand excavation. Hand excavation is a little bit expensive. It's more expensive than machine excavation. However, some particular place, we still need the hand excavation. So let's see what are those particular places that require this kind of excavation. And number 5 is machine excavation. Excavation is machine excavation. We use the machine, meaning the different type of machine. So you can see that now is excavator is most common one, and we have rock excavation. So if we encounter rock at a rocky area, so what method should be applied? Sheeting and bracing. Sheeting and bracing, so meaning that in order to as I said about the soil condition, so some place the soil condition is not really stable, so we really need sheeting, and we really need bracing. So what should be the method to do sheeting and bracing? So we're going to discuss in this 7. The removal of sheeting and bracing. So after the construction, we need to remove all those sheet pipe or timber sheet and timber brace or etc. So we need to, what are the method to remove all of it? And then we have a dewatering of trench. So sometimes we encounter the water inside the trench. For example, let's say the water table is like a little bit higher, is higher than the sewer, the invert level of the sewer. So it will be a big problem for us to work, especially during the excavation period, excavation to lay the pipe. So we have to dewater to make sure that the site is dry. We can work on it. So we will, let's see what are the method that we are going to use for dewatering of trench. Pipe laying, pipe laying. So after we take care of the trench, so now we can lay the pipe. Okay, so we will see what. And then we have a joining. We have a jointing. So this joint, we need to join from one pipe to another. So what are the methods that we're going to use? And then we have a jacking and boring. So jacking and boring is it's like when we encounter, like, you know, like if the pipe pass through highway, the pipe pass through like river, or the pipe pass through any particular place that we cannot make excavation or require trenchless, so we need to do checking and boring. So after we do the trench, so now it's backfilling. So we have to refill the soil inside the trench, or we have to cover the sewer with material. So this is the discussion in this part, backfilling. And then number 14 is tunneling. So it's almost the same with checking and boring. So if the place, mostly if the place is more than, I mean, if the trench, the trench depth is more than 8 to 9 meter, so we have to consider about the tunneling, because sometimes tunneling cost is more competitive. I mean, it could be like the same or cheaper than excavation cost. Okay, so this is the let's get into detail about. Number one is responsibility. So the engineer, as I said, we have responsibility, have two, engineer and contractor. So issuing the plan and specific, issue the plan, issue a specification of sewer work, is the work, is the responsibility of the engineer. And the engineer also have authorization, has an authorization for any change during the course of the construction. The engineer again control to prevent the foreseeable trouble or delay. The engineer have power to control. I mean, to control and also to prevent any future trouble or delay. They should have this ability, and the engineer itself have to have the ability to decide on the location of the line and grade with responsibility of applying with the plan. Okay, and then for the contractor, contractor has responsible for method and scheduling, and they also need to decide on the location of the line and grade. So during the decision on the location of line and grade, both engineer and contractor can work together to get the best solution at the field. So usually the actual construction of sewer consists of excavation, dredging, and dewatering of trench, pipe installation, backfilling, and construction of appurtenance. Okay, so as you know, appurtenance is, for example, manhole. Okay, number 2 is line and grade. So in the large city, usually in the large city, so the plan is to avoid existing underground structure. Okay, so in the large city, first of all is we have to have, I mean, the line and grade should be planned to avoid existing underground structure. For example, let's say pipeline, water pipeline, water main, electricity, telecom, cable of the telecom, etc. So this is the we have to avoid. And in small city and in sparsely settled residential district, so less care is needed, and generally only water main need be avoided. So meaning that at the small city or at the place with the scattered residential area, so water main is important. So sewer should avoid this water main line. And in a new construction, so the middle of the street will be chosen, so that the house sewer, which are paid for by the property owner, will be equal in length to property on each side. So I guess that's why a lot of sewer is placed in the middle of the road. Just to make sure that they have no argument about the house owner pay the fee when they connect to the main sewer. An offset line is collocated where it will not be disturbed or covered. This is like at the beginning of the job. So the offset, we have the center line. After that, we offset the line. We offset the line, and then this offset line should not be obscure. Okay, it have to be seen. And then the contractor then measure from the offset line and lay out the trench on the ground. So from the offset line, so now the contractor will make sure that they, draft they can lay out the trench, like dimensional trench on the ground. And then when the excavation is nearly complete, the better board are placed across the trench at 10 or 15 meter interval. So a butter board is like this. So this is the butter board. Every 10 to 15 minutes, every 10 to or 15 meter interval. So we put this butter board, and with the station mark. So maybe this is like station 1, station 100, etc. Station 1, station 10, etc. So the center line of the sewer are indicated on the butter board by a nail or by the edge of the upright cleat and another edge of the indicating line. So elevation are then run, and a mark is placed on each cleat at some even distance above the invert of the sewer. Okay. So this one. So this is the elevation. So the nail is driven in the edge of each cleat at the grade mark, and a cord is stretched from the cleat to cleat. The line is transferred from the cord to the bottom. The line is transferred from the cord to the bottom. This is the cord. From the cord to the bottom by or the trench by means of the plumb bob. So it's, something like this. We drop the plumb bob to the bottom. Grade is transferred by means of a stick mark in even increment and having a short piece fastened at the right angle to its lower end. Okay, so then after we got the line, okay, we got the line, and then we transfer the grade to the lower end. The grade is checked by placing the short piece on the invert of each length of the sewer pipe and noting whether the proper mark touch the cord or not. The sewer technique is maintained both line and grade. Employ a laser beam generated at a manhole and directed down the pipe as it is placed. So accuracy of line and grade can be had to within 0.01% over a range of 300 millimeter, 300 meter. So, but right now line and grade is easily applied by using, like, we have what is it, like automatic leveling. We can use leveling to do the job, or we can use the theodolite, but mostly we use the leveling to get the elevation, leveling to get the elevation, and then apply for the grade. Okay, number 3, classification of excavation. So excavation is frequently divided into 3. we have the class A, class B, and class C. So class A consists of solid rock in the original bed or in a well-defined uh, uh, ledge, removable only by blasting and or by and of all border over 0.5 cubic meter in volume. So class B is excavation comprised disintegrated limestone, shale, soapstone, slate, happen, fire clay, cemented gravel, uh, macadam pavement, and border less than 0.25 cubic meter and more than 0.03 cubic meter in volume. This material can be removed by hand or mechanically with minor difficulties. So that is class B. And class C is not include all other material like soil, sand, clay. So we have hand excavation. So hand excavation is half to an absolute minimum in sugar construction. Hand excavation is half an absolute minimum in sugar construction. So sugar line should be located to permit the maximum use of mechanical equipment, with hand excavation being limited to intersection with existing and minor excavation at pipe joint. Okay, so at the intersection with existing and minor excavation at pipe joint. So this is we need the hand excavation. When hand dug trench exceeds 1.5 meter in depth, it is necessary to re-handle the material excavated at the bottom to move it further from the trench edge. So the minimum cell space should be over 500 millimeter. In trench over 2.5 meter deep, it is necessary to construct a relay platform at about 2 meter interval. So this is for the hand excavation. For the machine excavation is much less expensive than handwork and should be employed wherever possible. So when gas, water, or electrical conduit are encountered, hand excavation is required for short distances. So trenches are excavated using specialized equipment or standard construction machineries, for example, backshoe, clamshell excavator, or track line. So excavator permit excavation of trench with up to 1.3 meter, depth of 9 to 10 meter can be excavated, which with such equipment, and at a rate up to 10 meter per minute under the most favorable condition. Excavation of trenches should be carried below the final elevation of the pipe, so that the suitable granular backfill can be placed to avoid good bedding, to provide good bedding. When bell and spigot pipe is used, hand excavation have to be it's required for each bell after the bedding material have been placed. The excavation should be carried a minimum of 200 millimeter below grade for cut up to 5 meter and 40 millimeter for each additional meter of excavation. And for rock excavation and trench in rock should be made to a depth of 1/4 of the pipe diameter below the bottom of the pipe, but in no case less than 100 millimeter. The space between the trench bottom and pipe should be filled with granular material. So harder rock may be broken by drilling a row of hole and splitting off a mass of rock by driving in a plank and feathers. Explosive must be used with care in sewer trench, or damage may be done by to a nearby building. So you can, for the rock excavation, uh, we can use the plug and feeder, or you can use the explosive, but very rare to use explosive. Okay, sheeting and bracing. Sheeting and bracing. Trenches in unstable material require sheeting and bracing to prevent caving or collapse of the side wall. The danger to workmen and increase of construction costs justify all possible precaution to prevent extensive caving. The size of the trench that are more than 1.5 meter deep and 2.5 meter or more in length should be held securely by shorting and by uh, sitting and bracing. By sitting and bracing. Or slope to the angle of repose on material being excavated. So sitting is the term applied to planks in actual contact with the trench side. Braces are the cross pieces extending from one side to another. This one is sitting. Okay. So this is sitting, and this is the this is vertical sitting, and this is the beveling of vertical sitting, and a pulling board. It's a pulling board, and this is seat piling. So this is Wakefield number 1. A is Wakefield timber. Thang and Grove, this is for timber, and Grove and Spline, this is timber again, and D is a steel. So this is steel. Okay, this is from, we look from the top. Okay, so removal of seating and bracing. So salvage of timber bracing and seating is usually practiced. So the braces are first loosened and removed, a process requiring caution and experience, or workmen may be caught in caving. If a hosting engine or crane is available, a loop of rope or crane is thrown around one or more sitting planks and they are pulled out. Hand pulling or timber sitting is done with a bar and clamp as in figure 18.8. If the sitting is pulled after the trench is backfilled, the friction force will not be developed and the load upon the pipe will be higher than original calculated. A satisfactory procedure is to pull the sitting in increments as the trench is backfilled, or to pull it part way and cut it off. Pull it part way and cut it off. In particular difficult soil condition where the danger of worker or structure require it, specification may be required that sitting be left in place. So this is removal of seating and bracing. Like this is like a steel clamp used to pull timber sitting, and this is, we can use crane like this to can pull it in or pull it out of the seat pipe. Dewatering of the trench. So if the groundwater table is above the bottom of the trench, water will flow into it. So such a condition require careful seeding and bracing, and also removal of the water by pumping. So if the trench is in a sandy material and the water flow is large, quicksand result and considerable difficulty is encountered. Unless the seating is of trenches is driven well below the excavation in quicksand, it will flow into the trench and undermine the site. Placing hay or straw in the trench bottom, weight it down with a brick bed or other heavy rubbish will stabilize the stand and permit water to rise without endangering a side wall until work in the trench is finished. So quicksand to can be best be combated by using well point. These are pipe like around 50 to 70 millimeter in diameter, point at the lower end, with a length of screen just above the point. The pipe are driven or checked into the ground in a line or on one or both sides of the trench, so 2 meters from the center line, 1 meter apart, and well below the water table. At 150 to 200 millimeter header pipe parallel the trench and have the valve branches connected to the pump. This arrangement lower the level of groundwater table below the trench bottom and keep it dry. When water is counter, but there is no trouble with sand, the usual procedure is allow it to run along the trench bottom to a sump from which it is raised and discharged by pump. Since this water will contain gritty material, only centrifugal pump, diaphragm pump, check pump, and vacuum pump are practical. So this is the well point. You can see here. This is the well point. So this is the well and the point at the end, and then this is the screen. So this is the screen, and then we inject all of this well point into along the side. Again along the side, and then we have the pipe, the head of the pipe like this, connect from one well to another. This pipe, like this is a series connection. This pipe will connect from all well point and then go to the pump, and then they will pump the water from this head pipe from each well point. This is also the same. Pipe laying. Before placing pipe, the grade of the bottom of the trench should be checked, and then a specification may require the grade be held within 10 millimeter of that on the plane. The pipe should be inspected to issue that it have no crack or defect, with particular attention being paid to the joint. Well and balance, because pipe is sometimes placed using a pipe hook in figure 18.9, but gasket pipe is better handled with a sling. So pipe laying are placed on line and grade after the trench have been completely dewatered. Laying are joined by pressing them together with the elevator or winch. The pipe is more easily moved if the portion of the weight remain on the sling. So this is how we'll handle the pipe. So this is a hook and chain following sewer pipe into the trench, and this is the winching machine to connect the pipe from one to another. Okay, joining. Joint it in ordinary bell and spigot pipe are made with Poland cement mortar or bituminous material. So cement mortar joint have the disadvantage of being rigid, and settlement of the pipe will cause crack with permit infiltration. Under a condition where groundwater table is above the sewer, bituminous material can be used. A better type of joint use plastic or rubber material which provides resilience as well as resistance to root penetration and infiltration. So Y and T branches for house sewer connection are placed wherever the plans indicate or in the engineer directs. They should also be careful located in construction field notes so that they can be found when a connection is to be made later. So this is like a showing. This is like cascade. This one pipe, this is another pipe, and this is mortar and the cascade. Cascade inside bituminous. This is good, and this is mortar. Okay, checking and boring. So installation of sewer and the highway, railroad, airfield, etc. may be accomplished without interruption of surface traffic by checking and boring. So we can use this technology, this machine. This is this machine. This is the auger boring machine to do the checking and boring. So the at the end, actually, the coring head and in the beginning, and this machine will rotate, or sometimes a rotary tool inside this pipe, and then core the soil, and then the pipe will be laid like this. This is one thing. Okay, backfilling. Trench should be backfilled immediately after the pipe is laid unless Class A bedding, concrete bedding is used. So fill material should be free of dust, debris, large rock and junk. No rock should be placed in the upper 400 to 500 millimeter of the trench, nor within 900 millimeter on the top of the pipe. The fill should be tamped with layer in the layer for 150 meter deep around, under, and cover the pipe to a depth of 600 millimeter. Earth should be dropped into the trench carefully until 600 millimeter of cover is in place. Puddling or flooding with water to consolidate the backfill is permissible only in sandy or gravelly material. When the trenches are in fill, the backfill above the 600 millimeter level is not tamped. All the earth is replaced. All the earth is replaced, and resulting mound is allowed to settle naturally. And then we have a tunneling. So where cut exceeds 8 meter, the relative cost of tunneling compared with other reconstruction should be considered. So you can see, can use this one. This is panel control this machine, and it's structuring, casing, and ventilation hose in here, or we can use this one. Okay, so inside this pipe it could be something like this, the spiral coring, something like this. Okay, so we move to the, let us break for a while, and then we go to maintenance of sewer.